Hello and welcome. Today we'll be going over an older video of mine by reworking and updating the code. This is going to be one part of an ongoing series where I will be updating some of my older videos and the code and handling different things in some just different and, in most cases, better ways. Today we'll be handling enemy AI and how we go about implementing basic behaviors such as patrolling or chasing. For this we'll be covering a simplified enumeration-based state machine pattern. Don't worry if you don't know what that means, I will kind of explain it as we go. I've kind of just throwing some words at you. If you get it, awesome. If you don't worry. To show you what we currently have set up here, we have a very quick scene here. It just has some platforms to move around on. It has a player script, which is the default movement script that Godot gives you. So nothing special, and we have a camera that is just following the player around. Once again, I will kind of go into that. Actually, I could shut that off a little bit here. Just getting the player, starting off with the position of the player, and then we're just handling the movement with some slab. I will probably explain something like this in a different video when we go back over cameras and things like that, but for now all it does is just follow the player around, nothing too special. Now as you can see here, we also have a bunch of enemies, right? We have 6 enemies just kind of dotted around. Is that 6 or is that 5? 1, 2, 3, 4, 5. That's 5. I can count. And these do nothing here. We'll look at the player script. Basic player script is the same one that the engine gives you, and the enemy script has nothing in it, but this is kind of what I want to go over today. Now, as a little starting point, what I want to start with is just getting the enemies to move, right? We just want the basic, what I would like to call patrol behavior, where they will move left and right, and if they get close to a ledge, they will flip and go in the opposite direction. So to handle this, we're going to first make sure we have our class name set, so we know it's an enemy. We're going to need to start defining some variables. The first one is going to be a constant. So we'll write const, then we'll write base underscore speed. This will be of type float, and we'll set that equal to 50. Now we're going to be needing a couple of things to, let me open the enemy scene here. We're going to be needing a couple of things, right? So when our enemy, actually it's probably better to show it here. Let's go to this platform. When this enemy here goes to the left, we want it to flip right, and when it goes to the right, we want it to flip left when there is no more path to walk. Now there's a lot of ways to do this. You could do area-based distance checks, you could literally do distance checks, or you could do 2 or 3 different types of raycasts. So there is one type of raycasting that I would like to use for this, because this is really, really simple. All we need to do is left-click on our enemy scene, hit Control A to add, or you can right-click Add Child, and we are going to look for Raycast 2D. So we have a raycast here, it's pointing straight down. I'm going to hold down Control and move this so it's moving by the pixel, and I'm going to put it at around -11 or just kind of 11 pixels in the left direction away from the enemy here. And then I'm going to duplicate that. I'm going to do that again, but this time I'm going to go 22-ish, that seems about right. So that's 11 on each side. Now I'm going to rename the Raycast 2D on the left to the left Raycast 2D. And on the right, I'm going to just rename it to right Raycast 2D. That's just going to help us know which Raycast we are kind of messing around with, right? So let's go into the script. Now let's make these as onReady variables. And to do that, we're just going to left click pull, Control drop, and it'll create the variable for us. I'll do it for both. So now that we have our raycasts kind of existing, we can start doing things with them. That's 3 of the 4 variables we need as well. So the next one is going to just be a little local variable. We're going to call this current underscore speed. This will be a float, and we're going to set that equal to 0.0. Now, you'll notice here that I have a base speed, which is just a constant, and a current speed, which is a variable that we can kind of mess around with. Now, the reason why I'm doing this is because having a base means we can apply modifiers to it in the future or do a lot of different things with it. One of those specific things we can do is if we come down in our ready function here, we can set the current speed equal to a rand f underscore range, so a random floating range between the base speed and the base speed times some variable. I'm going to go 2.5 because that's kind of the comfort zone that I found. Now this is going to give us a really, really big floating point. So the next thing we're going to do on top of this is go round. Let's do round f. And that should roughly round up the float. We may need to just change that to round in the future, but we'll see. And then all I'm going to do here to get our enemies moving is change the velocity. I'm going to set that equal to a vector2 dot right times the current speed. This is just presetting their movement, so they will always move right at whatever randomized speed they currently have, which is going to be nice because it means we can just get things moving. Now, to make sure that this is working, what we can do in the physics process is just call move and slide. I'm going to hit Control S and save, and that's it, right? That this is basic movement. Now, if I press play, this is going to break, and that is because I need to do something specific. Now, this is very much a me thing with how I've set this up, but as I said, camera 2D is trying to get the player for the first node in group player, but if player is equal to null, it will break. So what I'm going to do here is I'm just going to go if player is equal to null, return, basically don't run this, and under handle movement, I'm already doing that. As you can see here, I'm doing a one-line statement or a one-line return or an inline return, I think it's called, where I'm just having it all on one line because that just looks a bit cleaner. So what I should be able to do here is press play, and as you can see, all of our enemies are moving kind of indefinitely to the right, and that is because, one, there is no gravity being applied to them, and two, they're doing what we told them to do, right? So we have them moving. That's a start, right? We're modifying their velocity. That is a start. So next thing that I want to do here is just handle the gravity. So I'm going to write func handle underscore gravity. Handle gravity is not going to be needing more or less anything. It just, or anything passed through it. It's just going to need to do an if check. It's going to go if not is underscore on underscore floor. Then I want to grab the velocity. I want to set that plus equals to get underscore gravity. Now, there are some things here. Is on floor is specific to character body 2D, which is what the enemy is. It extends character body 2D, so we can call this functionality here, which is just a check to see if it is touching something on the bottom side of it or not. And get gravity is a system-wide thing, which allows us to get preset gravity functionality. Now, to make sure we're doing this, what I can do is go into project settings, and in the filter here, I can just search gravity. And you'll see here under physics, we have 2D default gravity, which I'm currently setting to 1200. That should be set to around 900 and I think 920 at a default, 980 at a default. I'm using 1200 because that, or 1200 because that is comfortable for me. And the default factor is basically which way gravity moves, whether that's down or up. So that's all get gravity is doing. It is not some custom function. You can call this in pretty much anything that needs gravity. I can do this, click, and find out. It's under physics body 2D specifically that has get gravity. There you go, more you know. And now what I'm going to do here is under the physics process, I'm going to make sure that move and slide is the last thing that I'm calling, and I'm going to call handle gravity like so. I'm going to press play. And as you can see, now they immediately fall off extremely quickly. Now the thing with this is the enemies don't actually really need to care too much about gravity. The gravity is more for the player jumping around. Now that is something we can change in the future when we had different behaviors. But for now, let's just keep going and let's get them flipping, right? Let's get them going from left to right and actually flipping how they look animation-wise. Well, animation-wise, sprite-wise, there we go. So to do this, under the handle gravity functionality, I'm going to just very quickly create a func. I'm going to call it check underscore collisions. Now, check collisions is going to be needing something passed through, but we'll get to that in a second. So with our check collisions functionality, what I think we now want to do is, well, check collisions is going to need a way of reversing movement and things like that, right? So first thing we need to do is we need to check if, okay, so the raycasts should always be colliding with the floor, and when they are no longer colliding, we want it to do something, right? And only one of these should be not colliding at like any given time. So we're just going to write if. So we can use an exclamation mark here, or we can write the not keyword. So we can write not left underscore raycast2d dot is colliding. This will basically just say, hey, if it is no longer colliding, then we want to handle our movement, right? And then we can do one more. We can go, I'm going to have the right pass there so this stops being grumpy with me. We can do one more. We can go if not right raycast 2D is colliding. Why is that? I don't know. we'll just ignore that. Dot is colliding. We are going to once again want to handle the movement. So I could just hardcode the movement in this, right? We are already currently doing that up here, where this is the current speed. We just modify the current speed, or we do something specific with movement. Now, what is it that we want to do with movement? Well, what we can do here is we can just go velocity is equal to a direction and a current speed. Now, we're going to need to actually, one, figure out the direction, and two, figure out the current speed that we want to move at, right? Well, we're already figuring out current speed up here, kind of. But I think what's going to be a better idea here is to actually create a helper function, or a function that is going to do just one specific thing that we can call and use in various ways, right? So to do that, we're just going to write a new function. This is just going to be called handle_movement. This is going to need to have a delta pass through, which is of type float, and it's going to need to have a direction pass through of type vector too. Now, why are those two things important? Well, we want to keep our movement frame rate independent, right? So the way we do that is by passing through delta. And we also want to pass through the direction that we actually plan on using. Now, I'm using an assignment there. I don't want to be using an assignment. There we go. So delta and direction, that's what we want to pass through. So to use this, in this function, all we're going to do is set the velocity equal to the direction times the current speed times delta. Now, one thing I like to do here, now I don't really know if this is a good idea or a bad idea, but I like to just kind of parentheses around these. It just helps my brain a little bit and changes the order of operations a little bit as well. So yeah, that's our handle movement done. So what does that mean? Well, that means back in the check collisions here, we can just call handle movement, not handle gravity. We can call handle movement. And now we just need to pass through a delta and a float, but there is no way to get delta in here, which means check collisions is also going to be needing a delta of float passed through. So we'll get back to why and where that delta is coming from in a second. We'll pass through delta, and then all we need to pass through here is the direction we want the character or the enemy to move in when the left raycast is no longer colliding. And which way? Well, if we are no longer colliding left, that means we want to move right. So we're going to pass through vector2 dot right. And we can pretty much just copy this one line, paste it down here, and change right to, you guessed it, left. I can hit Control S and save, and that's it. We are now handling the collisions. So under handle gravity in our physics process, let's also just have handle collisions running. Why is that being grumpy with me? Have I spelled check collisions, not handle collisions? That's me with my naming conventions being wrong. And we now need to pass through delta. So if I just write delta here, you'll see we are actually, it's working. Why? Because physics process actually has delta. That is getting passed through somewhere else, and we can now pass that through check collisions, which can pass that through to handle movement. So I'm going to hit Control S and save. I'm going to make sure everything is set correctly, which it is. Now I'm going to hit play, and what should happen here is, well, they are moving, but they're moving extremely slowly. Now, the reason they're moving extremely slowly is because we are timesing our current speed by delta. So what I need to do here, more or less, is just kind of jack up our base speed a lot, right? So let's add an extra 0 to our base speed, hit play, and see what happens. Well, as you can see, now they are actually moving. And all we need to do here is make sure they rotate their positions. As you can see, because they all have randomized speeds, they're all hitting their points at different times, but they are changing directions. I'm going to knock this speed up to, let's go 1500, get them moving a little bit faster. And there we go. We actually have some collision detection in the, well, collision non-collision detection. You know what I mean. They're detecting whether they're about to fall off of a ledge or not, and then they're saying, no, I don't want to do that, and moving in the opposite direction. That is kind of perfect for what we need. This is the basic patrol behavior. But as you can see, if I jump down here, even if I'm in range of them, nothing is currently happening, and that is because we are not checking for, well, anything else, right? So let's get this speed going up just a little bit more. We'll go 1700, And I just want to set up something for debugging purposes that we can use really, really well. Now I'm going to go to my enemy scene here. As you can see, all we have is the sprite, the collision, and the 2 raycast that we just set. Now I'm going to highlight the enemy root, I'm going to hit Control A, and I'm going to add a label. Now this is just going to be a debug label, or a label for debugging purposes. I'm going to Control drag drop into the script here so we can create an on-ready variable for it. Now you do not need to do this. I technically do not suggest doing it this way. There are much better ways of doing this. This is just me saying, hey, this is something that we can do to kind of visualize a bit more what's going on. So in the process function, I'm going to just go to my label, my debug label. I'm going to set the dot text equal to, so I want it equal to a string, right? So at first I'm going to want the speed, so the current speed that it's at. And then after, like inside of the little string that I'm writing here, I'm just going to write %s. Now, %s is a formatting method or an insertion method where we can just write %, and the way I will usually say this is speed, where % is, so in this case, % is the current speed. Now if I hit Control S and save, come back to here, and we move this debugging label to somewhere centered up top, press play, this should be a bit huge. There you go, it's a bit huge. As you can see, the speeds are all a bit weird, right? They're all a bit weird. And that is because they are being multiplied by 2.5, and then they are being rounded, so these are some relatively high speeds. But as you can see, they all have different speeds, which is great. I'm going to hit Control S and save. I'm going to just very quickly modify this debug label just a little bit in the theme, overrides, font sizes, font size. I'm just going to set this to, say, 12 pixels and see how that looks. That looks a little bit better. I know I'm going to be adding a little bit more to this in the future, so I'm going to pull that up a bit to give more room. And I like how that looks so far. Yeah, there you go, randomized speeds. Now, if we look at this bottom right guy here, he has a speed of 1,977. I click play again, he now has a speed of 3,766, and the speeds should be different every single time. So that means we can actually kind of move on to the quote-unquote meat and potatoes of what we actually want to do, right? We want to actually add behaviors. Right now we're just moving left and right, and now that might be great for certain enemies, that might be all you need. But what if you want them to, I don't know, chase the player? Then we're going to need to do some things specific. Now, to do some specific things, what I'm going to do here is I'm going to go to the player. I'm going to go into the node here. Under groups, I'm going to click the plus icon. I'm going to make a global group, and I'm just going to call it player. I'm going to click OK. And now the player is added to the global group of player. If I save that, come back over, and as you can see, that is now grayed and ticked. So two things are going to happen. One, the camera will now start following the player, which is really nice, hence the camera script that I made. And now we can start actually adding the player or referencing the player in certain ways for our enemy. So to do that, what we're going to do here is first we are going to create a new localized variable, so var, and we're just going to call it target. It's going to be of type character body 2D. We're going to set that equal to null. Now I could just set this to of type player, right? Since my player has a class name of player. Now the reason why I'm not doing that is because it just might be a thing where they might not always just be chasing specifically the player. And this just allows us to go any character body 2D that you view as the target, chase, not just the player itself. So the next thing we're going to need, right, because we want to set up a chasing kind of behavior, is a variable for is chasing. So we're going to have that as a boolean. So it's just going to be a true boolean, and we're just going to set that equal to false immediately because it doesn't want to be chasing immediately, right? So with that, what we can now do is start working on the state machine. So let's come down here and then let's actually make the state machine. Let's go and create an enum, call it states. We're going to open up some curly braces like so, and we're just going to put in our patrol state and our chase state. And then just under this, I'm going to write a new variable. I'm going to call it the base. Actually, we'll just call it the current underscore state, and it will be of type. We'll just set it equal to states dot, And what do we want to start off with? Well, I wanted to always start off in the patrol state, right? Because it's not always going to have a target, so it's going to start in the patrol state. Now, I'm going really fast here, and you're probably like, wait, states, state machines, what are we doing here? Well, a state machine is more or less a logic gate, right? It's like an if statement, just a really, really cool if statement, where it's saying if the current state is equal to the patrol state or the chase state, run certain logic, or in this case, run the patrolling logic or run the chasing logic. So it's a really, really interesting and very expandable way of creating multiple enemy behaviors without going to kind of weird lengths to make really big if statements. That's kind of the very easy example. And I plan on making a series based on enumerated state machines, kind of some more intermediate node-based state machines, and then some more complex script-based state machines, which are really, really cool. But for now, this is all we technically really need to be working, right? But what else do I want to do with my enemy? Well, I want to have them all start moving kind of at different times. So what I'm going to do here is under my enemy, I'm going to just control A, I'm going to add a timer, I'm going to just create this, call this the freeze timer. Now, I'll just tell you why in 1 second. Create a variable for it. Do I need a variable for it? I don't need a variable for it. Actually, yes, we'll create a variable for it. So what I'm going to do here is under freeze timer, I'm going to come down to the inspector, make it one shot, and under ready here, I'm just going to go timer.start, sorry, not timer.start, freeze timer.start, and I'm just going to pass in a rand f underscore range, and it's going to be between 0 and 1, and that's just basically going to go, hey, 0.9 seconds, 0.8 seconds, randomly spit out a time, and then this is going to start, and it's going to run based off of that time, and then when it finishes that time, we're going to fire the timeout signal, which is under node signals timeout. Then we're going to connect that to our script as well. Now under here, we're just going to more or less do that thing that we're doing under the ready here, where we want to grab the velocity that we're setting, and we're going to paste that into the freeze timer. And we're also going to write is underscore, wait, sorry, is frozen. Did I not make that yet? No, I did not. Nope, I did not. So we're just going to write a new variable here for is frozen, which is a bool, and we'll set that equal to true to start. Come down, I'm just going to write is frozen is equal to false. Now, why is that a thing that I want to do? Well, this is something else that we could do, where I'm using a timer to basically dictate when certain things should happen, right? So what I'm going to want to do here is under my physics process, I'm going to want to go if is frozen. So if is frozen is equal to true, we just want to return. I can make that a one line as well, like so, keep it clear. And what this is basically just going to do is say, if we are frozen, don't do anything else, just handle the gravity, that's it. And then after the timer fires and is frozen is set to false, we can now start moving and things, right? So I'm going to hit play, go to wait. And as you can see, some of them started at the same time, some of them started at different times. Do that one more time. And there you go, they all started at slightly different times and they're all moving at different times. Why is that important? Well, it just kind of offsets what they're doing a little bit and it just looks a bit neat. Not really to do with the state machine, just a fun little thing. Back to the actual state machine here, now that we've got some basic freezing and unfreezing of everything. What we're going to do is we are going to add the current state into our little debug label to make sure we can check our current state. Now to do that, what I'm going to do here is I'm going to go space. Actually, I'm not going to even do space. I'm just going to do a \n, which basically is a new line. And then I'm going to write state. And then my little colon, space, %s. Now, this is going to function a bit weirdly now because we're currently saying the whatever %s is to current speed, right? But we want to set that to whatever our current state is. So if I try and just do current state here, as you can see, it's kind of grumpy with that, and then it's going to throw an error, and it's going to be like, what am I doing? Well, what we can do to fix this is we can highlight our current speed, we can add square braces around it, and then basically just do that comment and then add the current state. So Control S and save, press play, and what you should see here is now we have the state of 0, which is the patrol state, and the speed above them. That's going to allow us to kind of modify and keep track of or modify the label and keep track of our current state so we can make sure it's working. So let's get on to the actual state part of this, or the state machine part of this. Just under my physics process, I'm going to create a new function. I'm going to call this handle underscore states. This is going to need to have a delta pass-through of type float, a void return type, and inside of this we're just going to very quickly run a match statement, and we're going to match the current speed, current state, and that current state is going to be matched to something, right? So if current state is equal to states.patrol, being a bit grumpy with me, but that's okay. If it is equal to states.patrol, what do we want to do? Well, all we're really doing here is just checking the collisions, right? We just want to check the collisions and pass through delta, because right now our patrol state is just this collision checking state, really. It's just the checking of collisions and making sure we don't fall off of the ledge. And then, we'll do one more state check here for if it is the chase state, and we are going to want to do some sort of chase state handling. So I'm going to write handle underscore chase underscore state. This is going to have delta pass through to it as well, and that's going to get grumpy with us because the handle chase state doesn't exist yet. So let's come down to just below our collision check. Right function, and then I'm going to paste in handle chase state, give it a void return type. And what do we want to actually do here? Well, we're going to want to, one, get the position of a target and make sure, what direction that target is from, kind of in, right? So we know which direction we need to move. And then we're going to want to move in that direction. Well, this is where our helper comes in, right? All we need to do for our helper is just pass through the direction. We don't need to do any fancy calculations. This helper function's handling it for us. Cool. But that means what we do need to do here is get a direction underscore to underscore our target. And we need to set that equal to something, right? So, well, what target do we want to set? Well, we have a target up here, which is a character body. And we want to have a vectored left or right or 1 or -1 return. So a really easy way to do that is first we're going to write the word round. So we want to round something. And we want to round the position, so our current position, dot direction to. And as you can see there, it takes a vector. So I now just need to do the target dot position. So this is going to return a vector 2 of 1 or -1, depending on if we are to the left or right. And then what we can do is just call that handle movement function. That's handle chase, handle movement, and we just need to pass through the delta, and you guessed it, the direction to the target. So chase state is now handled, right? Now what I can do under the handle states is call handle state here, or handle chase state, which we're doing. And we just need to make sure that the chase or the handle states is being called now. Now, which that kind of means is instead of check collisions here, we can just call handle states, pass through that delta, and we're done. That is very quickly simple, like state behavior, but you're probably asking yourself, well, how are we actually, getting into the chase state? We're not having a trigger for that. And if that is kind of your guess, congratulations, that is correct. We don't have a trigger for the chase state yet. So to make that, what we're going to do is click on our enemy, we're going to hit Control A, we are going to add an area 2D here. Let's go back into the 2D scene, go to the inspector, and it's going to be needing a collision shape as well. Now I'm going to just add a capsule collider here. It doesn't need to be a capsule, I just am using one because I feel like using a capsule collider today. Now I need to, that's the wrong button, I need to rotate this, and to rotate I'm going to click on the little rotate mode up here, which is E on your keyboard. I'm going to hold down Control so it snaps 15-degree increments, like so. And now I'm going to just move that to kind of where I want it. A little bit above is okay, and as long as it's centered, we're happy. And then I'm just going to expand this box a little bit more like so. And that's it. That's our little, hey, this is where we are going to chase. So I'm going to call this area 2D the chase area 2D. I'm going to hit Control S and save, go back into the script. And now we need to just finalize this, right? We need to figure out how we're going to be handling this. Well, we come to the chase area 2D, go to node, signals. There are a few signals here that we could actually use. Specifically, we could use body entered and body exited signals. So let's just connect those up to the main script. Like so. So now we have these kind of being handled. Now, what does that mean that we can do? Well, what we can do here is we can check. We can check if the body dot is underscore in something, right? But specifically, we can check if it is in the group. And then we just need to pass through the group of player. Now, this is how I used to kind of go about this, where I would, I'm doing multi-line there, just ignore that habit. What I would used to do is I would just kind of put in player, and this is kind of okay, but it is, it's annoying because it's a floating kind of string, and if we change the player group at any point, that can be problematic. So what I like to do now is just at the very top here, add a new constant, call it the player underscore group of type string, and then set that equal to this, like so. And then at the very bottom here, when we're checking if it is in a certain group, we can just check if it is in that player group. Now, if I've been moving a bit too fast, let me kind of reiterate what we're doing here. We are checking if the body that has entered the area is inside the player group, because if it's inside the player group, then it must be the player, which means we must chase the player, right? Or we can use that as a valid target because it's a character body 2D. So what does that mean we can do here? Well, that means we can now just, one, change that is chasing boolean to true, so we now know we are definitely chasing. We can set the target equal to whatever the body is. And then we can just change our current state, not current speed, current state, and set that equal to states dot chase. And that's it. That is it. Now we are triggering it, but we now need to make sure we are untriggering it. So what we can do here is we can hit Control C, copy this code that we've just done, paste it into the onBody exit. What we've got to do here is change the is chasing to false, and then change the current state to patrol. Control S and save. Modify this so it's a bit easier to see what I'm doing. There we go. And that's it. We are now doing what we need to do. So let's hit play. And as you can see here, they are all in state 0. Now, if I come and walk over here, you can see nothing is currently happening. Now, why is that, right? I'm sure you've probably, or a lot of people have kind of ran into this kind of issue before. Well, the reason why this isn't changing is because of how collisions are currently set up, and specifically our collision, mask, and layer. As you can see here, it's looking for layer 1 and mask for layer 1. But if I come to my player, as you can see, it's on player 2. And it's on mask 1, so it's looking for whatever's on floor, or whatever's on mask 1, which in this case is the floor, but it exists on the layer 2, right? Whereas this isn't looking for layer 2, this exists on layer 1 and is looking for 1. So what I want to be doing here is looking for layer 2. So let's see if this functions how we want it to function. As you can see, we are now chasing the player, and we will continue in that direction until we kind of hit a ledge. Let's just make sure that works. As you see, it hits a ledge, and that's it. Now, if I hit 1, or if I walk into the area, as you can see, state changes to 1, which in this case is the chase state. And every time I change direction, it is coming with me and actually chasing me correctly. And if I bounce out, it will just go back to making sure it doesn't fall off of a ledge. But that's it. That is more or less the basics of a really, really simple enumerated state machine using 2 specific states here for patrol and chase. We're just setting it, and then we're doing our logic based off of that. Now, as a little bonus here, what I want to do is create another little function just above the signals here. I'm going to just call this func handle underscore flip. And all this will do is, I've seen some people ask about this before, all this does is it just flips our character body, or it flips our sprite based off the direction we're looking. So what I can do is I can just go if velocity.x is greater than 0. Well, if it's greater than 0, what do I want to do? Well, I'm going to want to flip it because it's greater than 0 with the direction of my sprite. This is kind of something that you need to figure out on your own depending on kind of what sprite direction you start in. I need to basically flip, so I can just, for now, write flip, and I can just do a quick elif after this. And I can just do the opposite. Velocity.x is less than 0. I could then do flip, but as you can see here, I can't flip it because why? I don't have access to specifically the sprite. I need access to that, so I'm going to control drag drop, get my sprite 2D as a non-ready variable, and then in here I can just write sprite 2D dot flip h and set that equal to true, and then copy, paste, and set that equal to false, like so. That's not how you spell the word false. There we go. Hit Control S and save. Now I'm going to come back up to my physics process here. I'm going to put handle flip just above my move and slide. I'm going to hit Control S and save, and that's it. As you can see, they are moving left and they are looking left, and now they are moving right and looking right. And will this work with the states? Of course it will, because it's just handling the logic based on the direction. Now, this has pretty much been all I wanted to kind of go over today. In the future, I will be doing a much more robust state machine and then a more robust state machine after that. But you've kind of learned a lot today, right? You've created little helper functions to get things going. You've learned the really kind of fundamentals of how states and current states and just the state machine or enumerated state machine works. This, by the way, I can't state this enough. This state machine, this enumerated state machine, is going to be strong enough for most games that you would like to make going forward, especially if you're a beginner. And even then, this type of state machine has been used in so many different AAA games and AA games that have released that are, just pretty good as well. It's really, really powerful for how little this thing actually is. Now, we'll move on to more complex things in the future, but for now, congratulations, you're done. That's it. Thank you for watching, and hope you're having a good day and a great game dev journey, and I will see you in the next video.